So now that we've been introduced to polynomials, now we're going to work through adding and subtracting them in 3.4 and then multiplying them in 3.5 and dividing them in 3.6. So really some of this is things we've done before. So feel free to use what you've learned already. We're going to be calling it different things, but it doesn't mean that you don't know how to do this. So do kind of seek to see those parallels in things that we've already done. In starting with adding and subtracting polynomials, the key thing that we're going to be doing is looking for like terms. And this is something that we've done before. We just didn't call it all of this stuff. So in this example, as an example of adding polynomials, I have two trinomials that I'm adding together. And so they're in brackets just so I can see them as trinomials. But the first thing we're always going to do is drop the brackets and then combine the like terms. In both adding and subtracting, this is the name of the game. Drop the brackets and combine the like terms. So dropping the brackets here would just mean rewriting it because the positive is applying to everything in this bracket, and so nothing changes. I'd be looking for like terms as I go through, and then I'd be combining those like terms. So my final answer would be all of the terms collected. So 9x squared plus 8x minus 2. What we've done here is the horizontal method. There is a vertical method. You don't have to do these multiple ways, but it can be useful. So in the horizontal method, we're going to write out the polynomials that we're adding. In these, you drop the brackets and collect like terms. So in dropping the brackets, there's nothing to do on the first set of brackets. In the second set of brackets, it's as if that positive is being distributed through, which doesn't change anything, but it's going to when we subtract, which is why I'm saying it this way, if you're curious. Then I'm going to collect up all those like terms, and so I get a final simplified answer, a final simplified polynomial of 10x squared minus 5x. All of these ones you want to just do similarly. Because I get a chance to do this, we're intentionally dropping the brackets, which I know doesn't do anything, but it's as if we're thinking about that positive sign distributing through the second bracket. So rewriting it without the brackets. And then taking a look for like terms. I'd collect my like terms. My goodness, it makes me dizzy looking at this. And we're done. You could put plus 0, but it doesn't need to be there. It's not wrong if it's there, but the back of the book wouldn't have a plus 0 hanging out the end. Last one. We have two polynomials that we're adding together. We're going to drop the brackets and collect like terms. That's the name of the game here. And dropping the brackets doesn't do a thing. Collecting the like terms, it's a bit of a hide and seek game here. So you want to look for those like terms. Whatever code it is you have, highlighting, color coding, circling, whatever it is. So then gathering up my like terms, I get 2x squared plus 12. So there is an alternative approach. You can do a vertical method. So same as you can add 2 plus 4 horizontally, you could add 2 plus 4 vertically, right? Now, the thing when you're adding vertically, you want to line things up for their place value. When we're adding polynomials, we want to line things up for their like terms. And so this is my alternative approach, the vertical method. We want to make sure that the polynomial is in descending order. If there's any degree of the variable that is missing, write it in as a placeholder with a 0. Then line up the like terms and add. So these are my two polynomials in the first one. I want to rewrite them in descending order. So this would be negative 5x squared plus 4x plus 8. The second one, I'm going to line up underneath it. This one didn't have any missing degrees of the x term, and so I didn't have to put any placeholders in. This one, in descending order, it'd have a plus 8x squared, plus 7x, and a minus 8. So now I have them. If we take a look, they're all grouped. And so sometimes this appeals to people who like to have things all neat and orderly rather than kind of splayed out across your page. So now when I combine my like terms, I can see how things work. And so I'd have 11x, or positive 11x, I should specify, and a 3x squared. The next one, if I do this, I've got 2 or 3 different binomials to add together. So I want to write each one in descending order. And if any have a missing degree of my variable, I want to leave a place for it. So this one here, this 3x squared plus 2, doesn't have an x term. And so I'd put plus 0x, and then I'd leave that space, preserve the value, but now I've got my x terms all lined up. The last binomial to add doesn't actually have a squared term, and so I'd start in this column and make it look like that. You could add plus 0 and you could add 0x squared if you wanted to add in all the missing degrees here, but in any case you've got them all lined up so we can add these things vertically. So we'd end up with a negative 1, we'd end up with a positive x or a positive 1x and a 6x squared. So that would be your final answer. And you could do this horizontally or you could do it vertically. We will be doing multiplication in a vertical sense, and this is a skill that does come into play. And so perhaps it is something that you just really like seeing all of your columns nice and neatly lined up here. But if the other way, the horizontal method's working for you, no big deal. It's absolutely fine. So we are going to remember about distributing a negative sign. This is just a review. This is a skill that we're going to be using when we are subtracting polynomials. And so in this one, we'd want to make sure that we are paying attention to our negative sign. So when we have a negative in front, it's like assigning a negative 1 all the way through. So we'd have negative 2x and negative 3y. For m, we now have a monomial and a binomial. And this binomial being subtracted means we have to distribute that negative sign through. So watch your signs. It's the most common place that we make errors. And again, with these ones, that negative is being distributed through. And do just watch your signs as you work through those. So this is a goofy application. I don't think that anybody who has a company that sells aloe plants, potted plants, models their business in this way. But I left it in here because it's kind of silly. And really what it's saying is the profit that you make is your revenue minus your costs. And so this aloe company has modeled things out. This is your revenue, or an expression to represent your revenue, and this is the cost that you have of selling your plants, I guess. So the idea here is that your profit is going to fit this pattern, right? So my revenue is this 3, whatever it is, copying, can't talk. Okay, that polynomial, and I want to minus this polynomial. So if I want to do this, I have to distribute that negative. And this is in here to give us one slower explanation of subtracting polynomials. Whoops, don't switch your sign, Marianne. So that negative distributing through is going to flip the sign of all of those terms. And so now we take a look at our like terms and gather this up so we can help out our friends who are selling aloe plants and tell them how much money they're going to make. We could tell them that they're going to make 2y squared minus 3y plus $8. And I'm sure they'd be ever so grateful and thankful for our algebra work on that. So maybe a little more applicable here, the actual like kind of book work of this. I don't know if I sold you on the application of all that. In these ones, we're going to do subtracting polynomials. We're going to start with the horizontal method. So we're going to rewrite the problem if necessary and put those brackets in, right? And we're going to then drop the brackets like we did before. This time it's actually going to have an effect. We're then going to collect like terms. So same thing, drop the brackets, collect like terms. In this one, if you wanted to subtract 2 from 4, how would you write that? Remember, order matters in subtraction. Well, you'd have 4 minus 2. So same thing here. We want to subtract this 5x minus 3 from 8x plus 2. So that's why it says rewrite it if necessary from the way that it's asked. So now that we have it rewritten, we have this distribution of the negative sign. That's how we drop our brackets. So the first brackets we can just drop. The second brackets are going to have the sign switched on each of the terms. So after we've dropped the brackets, now we can collect up our like terms. Again, with the next one here, we want to subtract this from that. And so order matters. And remember the brackets because they do matter too. We want to drop the brackets and then collect like terms. So the first polynomial, we can just drop the brackets. The second polynomial, as we drop the brackets, it's that negative sign being distributed through. So it basically switches the sign on everything. Then we gather up our like terms. What did I just do? Something funky. Oh no, there we go. So what's something I was just kind of flustered over there is that it's not in descending order. In the back of your book, you would have these two reversed, but it's not wrong in that order. So long as the sign goes with the term, you're okay. Okay, so again, subtracting this from that. Whoops, not multiply, minus. Drop the brackets. And collect your like terms. Last few here, we want to subtract this from that. So rewrite it, drop your brackets, and collect up your like terms. This time I didn't get flustered and wrote it in descending order. Last couple, we want to subtract this from that. So rewrite it, drop the brackets, and collect like terms. The last one, just to keep you on your toes, you want to take this and minus that. So they're in the right order now. If I wanted to take 4 minus 2, right, that's how I'd say it. And so that's what this means. So 5 minus 3x plus 4x squared minus, they're in the right order this way. So drop the brackets. And collect your like terms. So that is the horizontal method. You could always do this in a vertical way. Oftentimes, this is something that's trickier for people, and we are not going to be doing long division with polynomials. You can thank me for that one later. And in this one, I'm going to show you how to do them, but really you can do it horizontally. And so if we're going to do this, we want to put them in descending order, leaving space for any degree. So it's very much like we were doing with the adding, lining up the terms. But this is the key thing. We still have to remember to distribute the negative sign. And so if I do these, it's this subtracted from that. So 8x minus 7, and I want to subtract 5x minus 3. Well, I take and do this distribution, changing this to an addition question, because that is my least likely way of making a mistake. Otherwise, I have to remember as I go down. And so my final answer for this one, because they're all lined up, would be that. And honestly, you don't have to do this vertically. If you're like, wow, horizontal was fine enough, then just go with that one. I will show us this one in a vertical method, but if you're not convinced, do it horizontally and you will be fine. So I take and rewrite it as an addition question, which is essentially distributing that negative sign through the second polynomial here. And then it's really just adding vertically. They're all lined up as like terms. But regardless, you'd get to the same answer.